is the chance of the
Yeah,
light going around the sample directly to the detector.
Okay.
Cool.
So if you put the
And
the
now, do you have? So it look. Can you show me that sample holder again? Looks like we might not be in there, right? Can you? Yeah. Yeah. Okay. So pop that guy out of there. Those little rings. So the sample goes underneath the ring. So you can. It looks like you have it sitting on top of it.
Yeah, but looks like it cannot go through.
It's a half inch. It's a half inch. No, so you have to pull the You have to pull the ring out. So yeah, pull the whole thing out of there.
It cannot go. I will try.
Yeah. So pop. Yeah. Take that out. Take that off.
Yeah, take that one off and then take the ring off.
So take the ring off.
And then take the ring out. And then now it looks like there's a spot on that sample. Is that right?
Yep. Should I put the ring on top?
Well, I don't think our sample is prepared very well. Can you give me a look at the sample? I can't see it. All right. You flip it over. Oh, okay. Yeah, that looks good. Sorry. It must have been a bad angle on my end. Actually, look, there is a shiny spot on the other side. You flip it over.
Yeah, probably here, around here.
The edge is fine. Flip it over to the other side.
Yeah, he says about these pages.
Okay, we can apply a little bit more.
Yeah.
I mean, okay. Yeah, start fresh though. You want even coats along the sample. If you have spots that are coated more heavily than others, it could affect the energy transferring through the sample.
Okay, he's fixing that right now.
Okay. I guess so. Be sure to remove the graphite that's already there and start fresh.
Okay, they are doing it here.
So clean the graphite that's already on the sample off, and then start fresh.
Remove the graphite.
Yes, like I said, if it has different thickness layers on there, it can affect the reading. So it needs to be cleaned off and reapplied.
How can we remove that?
I mean, you can do it with water, acetone, and water gets it off. Water and a rag. It comes right off.
Okay, he's going to he's removing the.
No problem.
He's removing that. Okay, so. This will drop the pressure very well to 2.6 millibars.
Yeah, that's good.
That's good then.
Because we're gonna have to before we run the test, we have to take it down again. So hopefully we'll get the same sort of. It's gonna take like a half an hour to get down. So.
Okay. So should we remove this ring in the other folders?
No, I mean we're not going to put anything in those, so it's fine. Those
Are-
rings, those
are-
rings are there.
Are we going to install it with the sample?
Install what?
Are we going to put this
Yeah,
ring
you
with
put
the
that over the sample.
Okay.
Yeah. So what that does is it prevents shine through. So obviously the sample isn't exact. You know, it doesn't fit exactly into the sample holders. There's a little bit of wiggle room. What that little circle does is prevent light from coming around the edges
Okay.
of the sample into the detector.
So what about if they want to run some samples like the one I showed you yesterday?
Talk to Justin.
Okay.
I'm not even gonna that type of sample is something that I've never worked with before.
Okay.
I don't want to
Okay.
speculate on prep for that, because
Okay.
to me it looks very porous, and you're gonna have a lot of shine through. Like the energy, the light is just gonna pass right through it. So I'm not sure how to prepare that.
How to prepare that. Right. It's here. Okay, they remove the black one.
And did you measure the sample already? The thickness? Antonio?
Hold on. Yeah, they are measuring the thickness.
Sorry?
They are measuring the thickness.
So measure it before you apply the graphite spray.
You have a pen? Actually, give me a pen. It's very difficult to find.
Okay, the thickness is 1.53.
1.53 millimeter.
Okay, keep in mind that we'll go through it in the software, but all of our thickness measurements have to be in centimeters. So just keep that in mind.
Okay. Okay, they are applying this layer of
Okay.
Okay, Josh. The sample is all set.
Can you take me over there real quick? Okie dokie. Looks good. Okay.
Looks good.
Let's close it up.
Let's close.
So how we can fix it?
This is push it to the front.
Yeah.
Okay,
Cool.
close.
All right. Let's turn do you have the gas on? Do you have gas flowing to the instrument?
Yes.
Yes.
Okay. Turn the vacuum on.
The first gas right now is open.
That's fine. That's fine.
So the vacuum.
Give it about 10 seconds and then turn the gas off. Perfect.
I cannot hear it. He's saying something.
I tell you. I tell you.
All right. You can turn the gas off, Antonio. Yeah. All right. Looks like we have a really good vacuum. Or is that Tor?
Yeah, right now it's at
Okay.
1.6 torques.
So we'll let that go for a while.
Yeah, it will take 20 to 30 minutes.
Yep. All right. While we're waiting, we need to fill the detector with liquid nitrogen.
Liquid nitrogen. Okay.
So that it should have been sent with a funnel.
It's about 1 liter.
Yeah. About, yeah. It'll probably boil off quite a bit, right?
Mhm.
Because it's still warm. So the first couple of
Okay.
the first little bit that you put in there is just going to boil off. But So we're gonna know it's full when it starts to bubble up
Okay.
around the opening. It'll take a little while though. It's because like I said, it's room temperature. So
Mm-hmm. Right now it's. Move it close to the needle.
did you guys put liquid nitrogen in there yesterday?
Yes, we did.
Okay, because it looks like it's full. Looks like it's bubbling up out of the side. So there might have been some in there from yesterday. Did you check the shot procedure in diagnostic mode?
I did.
Okay.
Okay, let's look and see.
Cool. So typically, you'll have to refill it every day, and if it's dry, you'll have to wait about 15 minutes before you can run any tests. But usually, it takes, as long as you fill it after you start the vacuum, it'll usually take about the same time, right?
Okay.
So.
Mhm.
It'll settle down. It'll settle down.
Yeah, it will settle down.
What's our vacuum gauge say? 98.
198 milliliters.
I'd like to see it get down to under 100 before we actually start a test.
Okay.
We're probably going to run a low temp test for this, but while that's coming down, we can set up our test.
Okay. Yes. Down. Slow, but it's moving. Okay, so you wanted to launch the software?
Yep.
All right. Right. This is the software.
This one flashlight.
That's the one.
Yep.
Yes.
Okay. So, if you move from kind of left to right here, open up operations.
Operation.
Yep. And then it says startup information.
The startup information.
Yes.
Uh-huh.
Yep. That's okay.
Mm-hmm.
Controller parameters, why? Using controller parameters. Why?
So if you look at the front of the instrument and you see that there's the temperatures are displaying correctly, right? So you have the furnace temperature and sample temperature. They look normal. So you do not have to send the program files down. So if you end up seeing, a lot of times you'll see just a bunch of U's, the letter U on the front of the instrument for the temperatures. If you ever see that, that's when you would send the controlling parameters down. But for now, you're okay.
Okay, so let me repeat that. If you see in this, for the temperature thermal correct, you can see that there is something is wrong. You have to say yes here.
Yes.
Right now, the temperature looks
Yes. So that should be in what range?
It depends on which range. Right now, it was cooling down.
Yeah.
So that's why it was cooling. Most of the time, you will have lower than that. Okay.
So,
This usually takes a couple minutes to complete.
Patrick, please switch off the cooler. So we don't run the experiment. Yeah?
Right now it's not on.
So let's, because it's very noisy.
That is,
Yeah.
is the one that is making more noise.
So nothing has letters and all?
Okay,
Okay.
now we have this one. Configuration.
Yeah, so
Configuration.
this is talking about the sample holders. So for you guys, you have the 4 half-inch
12.4.
sample holders.
Mhm.
So your configuration 1.
I'm going to select the first one because those
Mhm.
are the we have.
Yeah.
Okay.
That's fine. Just click OK.
That's the first this and then keep OK.
Okay. So it's gonna be run in vacuum? Yes.
I mean, we don't. I was planning on running it. What do you guys have hooked up? Nitrogen or argon?
Right now, nitrogen.
Yeah. So we're gonna run in nitrogen. You can say no.
No.
Okay.
In which cases we need to accept yes for operation within vacuum? In which
Sorry?
cases?
Well, that's kind of up to you, right? Do you want to test your samples in vacuum, or do you want to test them in a nitrogen atmosphere? It's totally up to you.
Yeah, I mean, what is the pros and cons? I mean, we can run any test, so within vacuum or within nitrogen liquid. So, but what is the pros and cons for which experiments is better to be
So
conducted under
that's a
vacuum
good question. That's a good question for Justin,
For application.
the applications group.
application
You have to
engineer?
ask that to the
Yeah, because
application.
it's gonna depend on your sample, right?
Okay. So now we have this one.
Yeah. So so here is where we set up our test, right? We type in the sample information, we create a temperature profile, all that stuff. So that first line there, you can type in whatever you want. For us, we're running steel, right? We're running stainless steel.
We are running steel.
Mhm. This is a
So we can just say like install, stainless steel install.
stainless.
Okay, and then
Install this.
install.
It's a reference that is when you install the instrument.
So the test ID field, that
Is
whatever you put into that is what the folder is going to be called. So it's going to generate a folder on the computer where it saves all the data. The name in this, whatever you put into this field, is the name of that folder.
Okay. So we can.
Now, it doesn't like spaces. There are a lot of character restrictions when it comes to this specific field.
Okay, and then sequence number.
Yeah, you can't change that, and you can't change the date.
We cannot change.
We cannot change it. Yeah.
Correct.
So, and then
Yeah, so now we just fill in the information. So the position is pretty self-explanatory. The position 1 is all the way to the left. Position 4 is all the way to the right. When you if you're looking at it, loaded into the instrument. So sample ID, we could just put stainless or SST, whatever works for you guys. And then same thing kind of for sample title.
sample title. I mean, is not.
Yeah, I mean for us it doesn't really make a difference because we're just running stainless. So if you have subtle differences between your samples, you can make a distinction there.
The thickness is in centimeters.
Remember, it's in centimeters. Thickness
Zero.
is always in centimeters.
It was 1.5 millimeters. I put 0.153.
Alrighty.
Not-
And we don't have to change the diameter because that's
Yeah,
restricted by the sample holder.
Like 10, it's gonna be 1.5 millimeter.
These are millimeters.
Yeah, it's 1.5 millimeter. It's
Yeah,
gonna
that's correct. That's correct.
converted to 0.5. Yeah. So, and diameter. So did you get?
It's
You don't need to change that. That's restricted by the configuration that we chose.
Okay, yeah, it's 0.2 millimeter. And then that's it. Wait. So how critical is inputting the weight, sample weight?
For this test, it's not. If you're running like a density or not a density test, a conductivity test, you may need that information.
Oh, okay.
Right.
So,
So-
what kind of test we are running right now? So,
This is just diffusivity. We're just looking at diffusivity numbers.
diffusivity. Okay, it's not conductivity. So,
Right.
Is that possible to conduct both diffusivity and conductivity experiments today?
Today, I can show you how to set up a conductivity test.
Characterization of conductivity is very critical to us.
Sure.
Majority
Yeah.
of our project is related to conductivity measurement.
Yeah, there are instructions in the help files as well, and I'll show you where to find the getting started guide, which it goes through all these steps. Like for us today to complete the install, we really just want to get a diffusivity test run and make sure those numbers are within, just to see the instrument function correctly, and then we can talk about how to set up a conductivity test as well.
Okay, so right now I'm not gonna input weight sample.
Right. Correct.
Okay,
So
that's it.
we're gonna leave the next 3 empty, right? Because we don't have anything in those.
Yes.
Okay. Now the next section here, this is where you set up your temperature profile. So on your sheet, where's your reference sheet? Let's choose a few numbers from there.
Okay, let's see. Okay, so I have a reference sheet with a column of temperatures, thermal diffusivity, and so
Yeah. So we're just gonna choose a few temperature points. We can do like, does it have a point at 100? Is that listed on there? I can't see it.
yes, 100. Yes, we have 100.
Yeah. So let's do 100 and 200 just to choose a few.
And
steps
the
there.
other one 200.
Yeah. Okay.
Oh,
Now-
can you please explain what is this temperature? I mean,
Those are the set points. So
Set.
the way that this instrument works is we can choose temperatures at which to flash the sample and take our diffusivity measurements, right? With stainless steel, we have that sheet that you have in your hand. We know the diffusivity range for stainless steel at all of those temperature points. Our goal
yes.
today is to verify that the instrument can take those measurements accurately, right?
Yeah, so it's not better to select one negative temperature and one positive temperature to
You
make
cannot
sure.
you cannot go negative in temperature with this instrument.
Uh-huh.
This is
Okay.
room temperature to 1200.
Yes. Okay. So 100, 200, so I input these values.
Yeah, so that's good. And what'll happen here, right? The next column is a ramp rate. So the
Yes.
10 is fine. 10 degrees per minute is fine. What it'll
Okay.
do is it'll ramp up to these set points and it'll hold it. I think it's 7.5 minutes. It needs to not change 1 degree in temperature before it'll actually take shots at fire the laser at the samples.
Uh-huh.
So the next column there is repeat points. That's how many shots you're going to take, how many times you're going to shoot the laser at the
Yes.
the sample, and how many
Yes.
diffusivity numbers that you're going to get, right?
Yes.
Okay. Power level is the voltage that the capacitor charges to. So that's the intensity at which the laser is fired at
Exactly.
the sample.
Laser.
1000 is fine for stainless. You might have to go up in temperature for more thermally resistive samples,
What is the maximum value we can input?
That's a good question. I don't know off the top of my head. Let me.
Okay, then so 1000 for power level. And we don't need separately set point 1, point 2, point 3, but so what is this? Point 1, point 2 is repeating points.
For some reason I can't get out of this. I'm trying to find your answer there. Just give me a minute. I'll look through the thing. Okay. So we can look on your computer. If you go to the Windows File Explorer.
Windows 5.
Go to the C drive.
TA.
Yep. Yep. There it is. And then if you scroll down, if you sort by type. Top. Yeah. Look for configuration.
Configuration.
Yeah, and there's a file that's fl5000.ini. Now look at the type is configuration. The file name is fl5000. Yeah, double click on that. So what we're looking for here.
First, set.
Yeah, there's a lot of information in here. Give me 1 second
Yeah.
So if you scroll down to the laser section.
To the laser section here.
Yeah, there's min laser powered and max laser powered.
Yeah, 900 is minimum laser power. 1700. Oh,
there you go.
1700.
So make sure you don't change.
This is just the range of laser power for a stainless steel for this sample.
No, that is for the instrument.
Oh, for the instrument between
Yes.
900 and 700.
Yes.
1700. Okay, thank you. Yeah, thank you. So.
Okay, so and like I said, 1000 is absolutely fine for for stainless because it has such a high high diffusivity. We're gonna be able to transfer that energy pretty easily. But if you're using some sort of polymer or a more thermally resistive sample, then you might have to increase the power level of the laser. The nice thing is if during the test the software doesn't register any kind of signal through the sample to the detector, it will increase the power level until it hits its max. Okay?
Yes.
So it excuse me. It will help you in that sense where if you have an unknown sample and you don't have a high enough power level, it will automatically increase it. Okay.
Yes.
It will not go the other way though. So if you're 1000 is always a good place to start as far as power level goes. Okay. So that's kind of it. On these other fields here, you can change the power level for each shot. So if you look at it, we have 3 shots, right? We're taking 3 shots. If you change the first point to 900, the second point to 1000, and the third point to 1100, it'll take the shots at those values, right? We don't really need to do that for this, but it's good to know that this is available for you. So go ahead and delete those numbers from there. Another nice little feature for this, if you see over on the right side where it says uniform.
Which one? Yes.
On the right side, it says, yeah. So you can set up So instead of typing every temperature point in, you can say, yeah, I want to start at 100, end at 1200, and increment at 100 degrees. So if you click OK,
Yeah. Okay.
yeah, so it puts all those temperature points in there.
Uniform rate 10.
Yep. So this is your. So if you change it to 5, you'll see it. You'll see the ramp rate change. Click OK.
Yeah.
And
Exactly.
then the same thing for shots, right? And power level. So you can go through and do this instead of having to type each individual thing in.
Yeah.
So you can,
Exactly.
Yeah. Okay.
And laser voltage or laser power.
Yep.
This is voltage or power?
It's a voltage. It's a voltage.
Okay, that's it. So
Okay.
we changed the RAM to 5 right now.
Yeah, this was just an example to show you how
Yes.
this works.
Yeah. So do you want me to return
Yes.
to 10? Yes.
So you can hit at the bottom there. You can say clear program at the bottom. Just hit cancel.
Yeah, I can change it to 10 right now.
That's fine.
That's it. Okay.
So at the bottom, just say clear program.
At the bottom, clear program. Okay.
Now you have to start.
Yeah. So now we can put our old, 100, 200.
100. 200.
Yeah.
That's
So you can save these programs and reload them if you like. At the bottom there, there are things for that. Okay. Does this make sense to you guys? This setup?
yes.
Okay. Cool. Let's Antonio. It looked like the vacuum was under 100.
Yes, it's in
Okay.
3.98.
That's fine.
84.
Cool.
84.5.
We can start to back flush. So because we're gonna run this test in nitrogen. So let's head over to the instrument and turn the purge gas on. Give it about 5 seconds and then turn the vacuum off.
So
Purge gas on.
the purge gas.
Yep.
You want to open it?
Yep. And then 5 seconds, and then turn the vacuum off.
You turn off. Turn on. Off.
Okay. So now we should wait until our atmosphere is back to 760 or 780, right? Because we're making sure that our chamber is now filled with nitrogen. Okay. Well, we're gonna wait until we see bubbles in the bubbler. That'll tell us that our gas is flowing through there. So, and that won't happen until 780 torr.
Okay, we'll wait for it.
Yep. It'll take a few minutes to get there.
Yeah. And then pretty much start the test, right?
Yep. And then we can start.
Now we can start.
No. Until we get to
No.
We have to wait until it gets back to atmosphere.
It's getting there. It's 100. Almost there, Josh.
Alrighty.
It's no, it's 200.
Yeah, what you can do to speed it up if you want is open there's a needle valve
Yep.
on, yeah, you can open that up. Just be careful,
Yeah,
as
yeah,
it reaches 780, you'll have to drop it back down.
yeah, I can do it. I've been doing this, so and it's open a little bit more.
Yeah, so when you open that up, you'll see it jump. But like I said, be careful as you see it approach 780, you have to adjust it back down.
So it's going faster now. Yeah, I open a little bit this one, so it's going faster. Okay, I'm going to start closing this a little bit. Okay, so right now we should start seeing this bubbles, right?
Yep. Yep. Oh, yeah. Once you start seeing bubbles, we can start the test.
Mhm. Okay. We got the bubbles. Mhm. Okay, so now we can start the run, right?
Yep. So I heard you guys turn the circulator off earlier. That needs to be on.
Which one?
The water circulator.
It's on.
It's on.
It's on.
Okay.
Yeah, what we turned off before was the
cooler from the other DSC.
Oh, got you.
This
Okay,
next boss, and it's really noisy.
got you. All
Okay.
right. Yeah, we can start the test. Yeah, like I said, the
Yeah.
it doesn't like a lot of characters.
So we should use
Just click
only
OK.
standard character. The expander is insert, yes.
No, so what this means, there's a little red expander that should have come with your instrument. Do you have that?
This?
The red circle. No, that's a cap for the.
We're talking about.
It's got a lens in it. That's it. So that is the if you're using the 1-inch diameter, the larger sample holders, you need to put that on top of where the laser. So the bottom box where the laser or the laser hits the sample goes into the there's a spot for that.
I know exactly, but okay.
Okay. And it looks like you guys don't have the 1-inch sample holder, so But that's what they're talking about. We just need to make sure that that is not mounted
Yeah, it's
for
going.
the
It has
half-inch samples.
the other sample. Yes. Okay. So just hit the OK.
Yep.
Please enable system.
Yeah, so on the front of the instrument.
Yep. We're going to hit the enable system.
Yep. And that should stay green.
Yeah, it's green.
Okay.
Now, OK. Make sure the cooling water is on. We're not using the vacuum. The purge gas, we have it on. And we have the liquid nitrogen, so it is okay.
Yep.
Do not connect to flash board FD.
You said you were able to shoot test shots yesterday, Antonio?
Yes, yes. Comport 5.
Okay. Oh, test isn't going to work. Go ahead and click OK.
Cannot sign to the check flash
Yep,
board.
click OK. All right. Open up the device manager. Close the software. Close the software and open on the device manager.
Manager.
Device manager.
Open up the ports.
Ports.
Okay.
It's in COM3.
What we need to do is disconnect the flash control board. So on the back, there should be one for the DAQ and flash control. There's a USB that runs from the instrument to the PC. There's two USBs. One is for DAC, one is for flash control. We need to disconnect the flash control board.
Let me see. In the back of the instrument.
Or on the computer side, whichever one's easier to get to. But the one that goes to the flash control, we need to disconnect and see which port that's currently assigned to.
Okay. I'm going to disconnect the first one. That is the one that is connected to the Belkin.
Look for the one that on the back of the instrument. There's two USBs. One is the DAC. One is flash control. We need to know which USB cable goes to which port on the instrument.
We only have one USB.
That should not be the case. Yeah, and take that hub out of there. That hub only usually causes problems. Connect them directly to the computer if you can.
This one?
I can't see. I'm looking at there you go. Yeah, you don't want to use that hub. That hub doesn't really work.
Okay.
There should be two USB cables coming from the instrument to the PC.
I have the first one. And this one is just this. Let's remove this one from here. looking for the other USB cable. Can you see USB cable?
Here, let me see if I can find the getting started guide. Maybe that'll help you.
Yeah, Patrick, when you want to move, don't feel.
Hmm?
When you want to move, don't feel.
Okay.
Yeah, so sometimes you need to help him.
That's not. Oh gosh, there is only one USB. The other one is this one that is, it goes to the,
There should be two. So like I said, there's a port that says DAC, DAQ, and there's another port that says flash control.
one that said okay, I see the flash control.
So these are things.
Yeah, so it looks like there's nothing on it. So right where it says temperature control, underneath of that, yeah, you got it.
Yeah, because
We turn it on.
we turn the. So. Okay, so we got the.
COM5? Good. Okay, let's try and run the test again.
So operation, setup information. Yes. No.
Running it.
I'm gonna share the getting started guide for the 1200 in the chat. Can you copy that and save it to the customer's PC?
Yep. He's going to share it.
There is the chat box.
No, he's going to share it,
Oh.
and then I
There's
will
supposed to be two
go.
USBs. Come out here, there's only one, and we found it. So now you guys
Okay.
Mhm.
we got it resolved.
Vacuum, no.
Redo
Then
the test.
everything
Start
is.
Which should
putting
be
on
easy.
the.
So
Yeah.
we just gotta be.
Stay still.
Where are the two USBs?
In the back. And they're just going
To the computer?
It didn't accept. This is the name.
DAC and
Huh?
temperature control.
This is the name of the folder.
Yeah, I
And
know.
it didn't accept spaces. So.
Oh, you didn't accept the spaces. Okay.
Mhm.
So.
So for the TSA we discussed yesterday, there was some procedures
Some
you guys
Everything is.
You're gonna
can
change it.
revise.
Okay,
So
okay, no change.
let me put the sample in. The first run,
It won't let me put the the getting started guide in the chat. I'm gonna email it to you, Antonio.
Okay.
Contact. So you're always gonna do the second one.
Things.
And whether you're putting out the first time, you do the second time.
All right.
They can do third.
I actually can't. My keyboard isn't working. I will.
Okay. Whenever you have a chance, send it to me.
I'll make sure you get it.
Temperature
The first one.
1200.
As when you put it in with solid, solid
200.
may have
I'm
different
going to use
content
the default for the others.
Right?
Mhm.
And the other thing you need to do
Yeah,
is
that's it.
you doing up right. You should do a downward.
Okay.
So you go up to 50 degree, you stay there for a minute, and you go down to room.
Okay, so start this.
A specific heat conduct between no.
No, that's okay.
Is not inserted for 12.5.
So it's the, you remember the red,
Yeah.
right now we're using the 12.7, so that's okay.
Expander, so means
If we're able to use the sample holder, the bigger.
okay. So but is not inserted. Expander is inserted.
Right now it's not inserted because we're running the small sample holder.
Are those menus?
No, those are just the drivers. The
Right.
manuals are here in the computer.
Okay.
Level system.
First from
Electronic.
Yes.
Mhm.
Yes.
Enable. Yes, it's green.
Yeah.
Okay. The
So
water
the
is the one
chiller
that
is
is in the
on.
corner, is on.
Check vacuum.
Vacuum, we're not running
Purge
under
gas.
vacuum. There is gas, so everything is okay.
So yeah. Right now you close the purge gas. Yes.
Yes.
Yeah. And
No, you
then
didn't close it. It's open. There should be bubbles in the bubbler.
Yeah, it's open. It's open.
it's open. Exactly. So the temperature, what is atmospheric? Make sure the other has been okay.
The purge gas is the nitrogen. Right.
Yes.
Please enable the furnace now. So
Enable
enable
furnace.
furnace.
Okay. And now we're showing.
So and what is this?
They're going to display it.
Yeah. So that thing means that the auto sampler is moving to the first position.
This one is in red, the fire. Is that normal? The fire in red. In red.
There is a red light, the fire. Can you see it?
Yeah. Don't worry about that yet. It hasn't gone through any of those.
What does computers have console?
Console? I'm not sure. Install it. So it doesn't matter if you install it on computer.
I installed it on my other computer, but it destroyed it because it had too many other heavy programs.
Okay. We can give you one to use. One. You need one?
Yeah, but I had
So what is this
because I have
numbers?
my in class. I gotta get that done.
You just what
Preparing the
Yeah.
test.
If I see that last semester, which is 12 cancel.
a fire and
Yeah.
Well, yeah. What was it in December, right?
Yeah. December 3rd. They sent me.
Well, it's just funny example for it.
Do you have any indication of how long the test should take? Is it varies every time?
Yeah, it's gonna be long time.
Okay then. So it says sample temperature 35.
Yeah, so now it's ramping up. It should be ramping up. It takes about 45 minutes to an hour for each temperature segment. So we have 2, so
Yes.
it'll be about 2 hours before it's finished.
2 hours.
Okay. It takes 2
Okay.
hours.
Yeah. Do you want me to call you back?
Sure. Yeah, it looks like it's going to run through. So
Okay. Yep. I'll call
Okay.
you back.
Okay. Yeah.
All right.
Thank you. So we'll talk to you later.
All right, sounds good.
All right.
Yeah.
Thank you.
Yeah. Bye bye.
Bye.
Oh, takes.
So for this